Welcome to a new video presented to you by APC Mastery Path. APC Mastery Path provides videos related to how to implement the latest artificial intelligence and machine learning within our beloved construction industry. This video belongs to a series of videos that will tackle how to use open-source LLMs to build a tool to convert PDFs to a functioning and useful podcast. The system that will be presented in this series relies on four main pillars. Pillar 1, PDFs loading and preprocessing. Pillar 2, writing transcript. Pillar 3, refining the created transcript. Pillar 4, text-to-speech workflow. We will discuss the whereabouts of Pillar 1 related to the loading and processing of PDFs in two videos. The first video will showcase how to set up the coding environment, load the PDFs, extract raw text and save that raw text in a file. The second video will continue to showcase how to use open-source LLMs to make sense of the extracted raw text and reword it to make more sense in preparation for the next steps. Having understood how we are going to tackle this project, let's dive in. This project was crafted by the Meta team and they have provided the full code on one of their GitHub repositories that I will be putting the link for in the video description below. I have also created my own refined code and uploaded it to a separate GitHub repository, which I am going to be providing the link for in the video description below as well. This will make the process of following through and implementing the project much easier for the listeners. We will start this video by showcasing the main output of the previous video where we have a raw text file that contains lots of irrelevant symbols, white spaces, and page numbers. The main output of this video is to have a cleansed text that will be the backbone for creating a transcript for our podcast. Step 8. Llama Preprocessing. In this step, our main goal is to set up the computing device to be used for model processing, choosing between GPU and CPU based on availability. Additionally, it defines a system prompt, sys_prompt, that will guide the model in performing targeted text preprocessing tasks. The prompt instructs the model on how to clean and reformat raw PDF data, providing clear guidelines on which elements to remove or modify. Step 9. Create word-bounded chunks from text. In this step, we are trying to create a function, create_word_bounded_ chunks, which splits a large block of text into smaller chunks, ensuring that each chunk is close to a specified size, target_chunk_size, without splitting words across chunks. By maintaining word boundaries, the function produces more readable and contextually coherent chunks, which is ideal for text processing tasks that rely on complete words and phrases. The end result of this step is to have a list of chunks, each approximately the size of target_chunk_size, with each chunk ending on a word boundary. This prepares the text for further processing by ensuring that no words are split mid-chunk. Step 10. Load and optimize language model with Accelerate. This code sets up a language model using the Hugging Face Transformers library with the Accelerate library to optimize model deployment across available devices, like GPUs. Specifically, it loads Meta's Llama 3.1-8B Instruct model, a large language model intended for generating and processing natural language text in an efficient manner suitable for larger systems or distributed setups. This allows the model to leverage the available hardware effectively, particularly in environments with multiple GPUs or mixed precision settings. The end result is a ready-to-use model and tokenizer that are optimized and prepared for high-performance inference tasks, such as generating text responses to input prompts. Step 11. Process text chunk with language model. This code defines a function, process_chunk, which takes a chunk of text and processes it through a language model. The function simulates a conversation by feeding the text chunk as a prompt to the model, which then generates a response based on the provided input. The function returns the model's processed output, making it useful for handling text generation in smaller, manageable segments, chunks. The end result of this step is a function which outputs the generated text response for each chunk, displays both input and output for monitoring purposes, and returns the processed result. The processed text is then ready for further use or to be saved. Step 12. Set up text processing parameters and chunk input text. Here, a setup is undertaken for the initial parameters needed for processing the input text by defining where the text data is stored, input_text and input_text_path, and specifying the size of each chunk, chunk_size. It then breaks the full input text into manageable segments, chunks, based on word boundaries, making it easier to process large amounts of text piece by piece. The end result of this step is a list of chunks, each containing a portion of the input text limited to chunk_size. The variable num_chunks holds the total number of chunks created, which provides insight into the workload for further processing. Step 13. Load input text from file and set up output file path. This step is all about reading the input text from a file, input_text_path, and calculating the number of chunks based on a predefined chunk size, chunk_size. It also generates a name and path for the output file, ensuring it will be saved in the same directory as the input file. This setup is essential for organizing and storing the processed text output in an orderly manner. The end result for this step is an input text, which is loaded and ready for chunked processing. Also, the number of chunks is determined, and a designated output file path, output_file_path, is set for saving the final processed text. Step 14. Process text chunks and save processed output. This step tackles the processing of each chunk of text individually, appending the results to processed_text variable and writing each processed chunk directly to an output file. It utilizes the TQDM library to display a progress bar, giving visual feedback on the chunk processing progress. By saving each chunk immediately to the output file, this approach avoids potential memory issues when handling large text data. The end result of this step is having a fully processed text, which is saved to an output file, output_file_path, with processed_text containing all processed chunks in memory for further use or inspection. Step 15. Display processing summary and preview processed text. This is the final step of this pillar. The aim here is to provide a summary of the text processing, displaying key information such as the input and output file paths and the total number of chunks processed. It also includes a preview of the processed text, showing both the beginning and the end of the processed_text content. This allows for a quick inspection of the final output, ensuring that the text has been processed as expected. The end result of this step is a summary of the processing operation, including a preview of the processed text. The beginning and end sections of processed_text are displayed, offering insight into the transformation and completeness of the output. Having undertaken all the steps above, we can now see the cleansed extracted text after the direct involvement of our chosen open-source LLM in the text transformation process. The cleansed extracted text now contains much less unnecessary white space. It also includes a large number of meaningful sentences with some areas rewritten or removed where irrelevant. This cleansed extracted text will now serve as the backbone for the next step, which is writing the transcript. We will be discussing this in our next video. All the files that we are explaining in this series of video are available on my GitHub repository, provided in the video description below.
Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of them other videos about fine-tuning large language models and deploying them to OpenWebUI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RSCS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.